Assalamualaikum warahmatullahi wabarakatuh, and very good morning. So this is the first topic for SEEE 2423 or SKEE 2423. So the first topic is about AC power system. Okay, and before we proceed with the topic, so I would like to have you some revisions on what is DC circuit and AC circuit. So as can be shown here, so this is a voltage source for AC circuit where you can see that the voltage is actually time dependent and cyclic in nature. So we have a frequency, we have period and so on. And for the DC circuit, so here this is a DC source here, so it is a constant and is actually time independent. Okay, and this shows some power system generations and transmissions and our and home appliance here if you are using DC system and for AC systems. So actually there are benefits, advantages, limitations for both systems. Either we are using DC system or AC system. So both have their own advantages and their own limitations. And for AC systems, so I would like to remind you on the revision on what you should know about the voltage, the current, the time relationship between the voltage and current, and what about the phase angle. Okay, so depending on the components inside the AC circuit, so the voltage and current can be in phase, meaning that there is no phase difference. Okay, and they also the voltage and current also can have some phase difference, so it's actually depend on the component. Usually when the circuits AC circuit contains only resistor, so you mostly will get the voltage and current are always in phase, while if your circuit contains rather than resistor, for example inductor and capacitor, so you will have different angle between voltage and current. So you should do some revisions on this, okay, the relationship, the time relationship between voltage, current, and also the phase. And so this is actually a video, so I would like, I will not show it here, so you can actually go to the YouTube and search for this title, ACBS DC power. Okay, so the problem when we have two powers. So sometimes maybe one of the student or maybe one outsider, okay, that will ask you why we need both power system. Why we need DC power system? Why we need DC power and AC power? Why didn't we stick to only one system? Okay, why we didn't put why we didn't stick to only DC power system, and why we didn't stick to only AC power system? Usually DC power system. Why? Because as you may notice that all our home appliance, your handphone, your televisions, your computer, desktop, are always actually required DC power instead of AC. Okay, so they are actually DC powered devices, because most of our home appliance right now is actually built up by semiconductor, okay, electronics system, where they mostly are powered by using DC power. Okay, but okay, so our home appliance are mostly DC, so why we need still AC power? Okay, so actually this AC power has advantages in terms of generations. So in terms of generations, AC power system is much more cost effective compared when you are using DC power for the generation. Okay, and also for the transmission. So DC power, if you transmit power in DC form, it will cost you a lot of money because you need to have a copper cable that is very solid copper cable, and usually the losses is also very high when you want to transmit the power from the generator to the home. Okay, so that's why we are using AC power instead of DC for generations and for the transmission. So that's why right now we are still stuck in both systems. So usually our generation and transmission, we are using AC power because they are much more cost effective, but our load is using DC. So we cannot run away from these both systems. Okay. Okay, so before we proceed, okay, so I would like you to maybe think something about this circuit. So based on what you have studied, okay, in the previous course SEE 1023, so can you calculate for me what is the power for this circuit that contains DC power, DC voltage here, a resistor, a 10 ohm, and given to you is actually an inductor 1 millihenry. So I leave it you the answers, the solutions. So actually we will discuss this in our class. Okay. Okay, so we go to our main topic here is about AC power. So this is the outcome. Okay, so the student should able to differentiate between the instantaneous and average power in AC circuit. That is the first outcome. And the second outcome that the student should know and understand the type of AC power available when your circuit contain resistor, inductor, and also capacitor elements. So this is the outcome. Okay, the two outcome from these topics. Okay. And this is the presentation outline. So we go for some introduction first, and then we directly go on the derivations of what we call instantaneous power, and then average power, and what is reactive power, and type of power in passive elements. Okay, so based on the time passive sign conventions, so if the elements is actually absorbing, okay, absorbing power, so the power should be a positive. So if the power is generating, so if the sign will be negative sign. So this current is going into the positive terminal of the element, so meaning that this circuit is actually absorbing power. So we have the power consumed by this element is PT, meaning that this is AC power is equal to the multiplication of the voltage VT and multiply with IT. So VT and IT meaning that this voltage and current is actually AC. Okay, AC voltage and AC current. And the multiplication of V and I will give you the AC power. Okay, so when it is multiplied, okay, where if the voltage here is a function of cost function here, and the current is also a cost function here. So when V and I is multiplied, you will have these equations. Okay, so PT is the instantaneous power, so equal to these equations, or it can be also written as the second equation here when we refer the current as our reference. So all the angle theta I is actually transferred to this one, so it will become theta B minus theta I. And further, when we are using trigonometry identity, this one, so we can actually expand the instantaneous power equations to this, okay, to this equation here. Vm Im Vm is your maximum voltage magnitude, and Im is also your maximum voltage magnitude, and theta V is minus theta I is actually your phase difference between voltage and current. And using the trigonometry identity for this one, okay, so we can actually rewrite the equations to these equations. So right now we have three terms, okay, the function right now, the instantaneous power has three terms. So Vm over 2 cos theta V minus theta I plus Vm over 2 cos theta V minus theta I multiply with the cos function with a 2 omega t minus 2 Vm over 2 sine theta V minus theta I multiply with the sine function 2 omega t. And from that equations, okay, so we can actually simplify. So we define the first term as what we call P, which is, this is actually what we call the average, or sometimes also the people call real, or sometimes also active power, which is P, and it is measured in the unit of watt. Okay, so this is the equation. So please bear in mind, so P here is a average power. Okay, this is not instantaneous power, so this is the average power. The equation is Vm Im over 2 cos theta V minus theta I, and the unit is watt. And the second function is a P multiplied with a cos 2 omega t, while the third term here we have Q. So Q is actually Vm over 2 sine theta V minus theta I. And this Q is defined as what we call reactive power, and it is measured in var, unit var. Okay, so right now we have introduced you three type of power in AC circuit, which is the instantaneous power, which is actually the power is always oscillate depending on the time, okay, time dependent. And from this instantaneous power, we define what we call the average power. The unit is watt, okay. And the third power is what we call the reactive power, which is var. Okay, and then next we will actually this one will be further elaborate in our next topics. Okay, so actually inside we will go further. So actually in the AC circuit we have introduced you uh, what you call the reactive power var, and we have what you call P. So this is Q, P, and we will actually introduce you later what we call the apparent power. So actually this is apparent power. Okay, the summation of real power and reactive power. Okay, we go back to the instantaneous power. So this is the instantaneous power equations. Okay, and this can be plot. So based on this equation, so we can plot. So for example, if we have a voltage and the current, which is in cost function, where we have some phase displacement here. Okay, so the instantaneous power is just a multiplication of Vt multiplied with It. So when we multiply, we will have this waveform. So this waveform is actually is the plot of the instantaneous power. So as mentioned before, so this instantaneous power is actually time dependent, where it is actually oscillate. Okay, and as you can see here, the power is actually positive and sometimes negative. So positive meaning that the circuit is actually absorbing the power, okay? And when there is a time where the power is negative, so meaning that there is the circuit is actually supplying energy back to the source. Okay, so it is actually oscillation, positive negative, meaning that the circuit, this type of circuit, where it's actually sometimes is actually consumed and sometimes it actually supply. So actually this waveform is actually not a general waveform. So it's actually depending on the elements inside uh, the circuit. So as I shown you before, so actually when the circuit is actually a resistor, a pure resistor circuit, so usually there is no phase displacement between voltage and current. So so that's why I say that this instantaneous power waveform is actually depend on the elements of inside the circuit. So let's go when the circuit is purely resistive circuit. So when the circuit is purely resistive circuit, the phase displacement between voltage and current is almost zero, which is the voltage and current are in phase. So when there is no different phase, so the term of sine theta b minus theta I inside the instantaneous power will become zero, and the cost function will become one. Okay, so when you substitute this in this value inside the instantaneous power, you will have that we have only the first and second term only, while there is no third term, because sine theta b minus theta n is actually zero. And this shows that for the reactive, for the purely resistive, okay, we have only P, which is the active power, and there is no Q. Okay, Q is zero because this term sine theta v minus theta I is zero. And when we plot the instantaneous power for a circuit that contain only resistor, so you will see that this is the plot of the waveform. Okay, P plus P cos 2 omega t. So as you can see here, the waveform is always positive. There is no power, there is no negative power, meaning that this circuit only absorb power, which is actually similar to what we have studied in your circuit theory. Resistor only absorb power. Resistor cannot supplying power back to the source. Okay, so the circuit only absorb. Okay, and we go for the purely inductive circuit. So when the circuit has only inductor inside the circuit, so the current will always lag the voltage by 90 degrees. So the different phase will be positive 90 degrees. And when you substitute this into the sine term in the instantaneous power equation, you will have this one become 1, and the cost term will become 0. And so the instantaneous power equation will become only third terms only. The first and second term is 0 because P is 0 due to the cost term theta b minus theta I is 0. So this means that for a circuit that contains only purely inductive circuit, meaning that only have an element of inductor, okay, the instantaneous power is negative Q sine 2 omega t. So when we plot here, so we will have like this. So this is the plot of your instantaneous power. Okay, so as you can see, the power sometimes negative and positive. Okay, meaning that this circuit, sometimes they will supplying the energy, the Q, okay, the Q back to the source, and sometimes they will actually absorbing the power to the from the source. Okay, and I would like to highlight that for this Q, the reactive power, so the value is positive 1 over 2 Vm multiplied with Im. And we go for the circuit that contain capacitive, okay, capacitor. So the current will lead the voltage by 90 degrees, okay, and so the phase difference is negative 90s, and when we substitute to the sine function here, so we become negative 1, and the cos function will become 0, and again we will when we substitute this, the average power will become 0, and the reactive power will be negative 1 over 2 Vm Im. And the instantaneous power, which is PT, is equal to positive Q sine 2 omega T. So as you can see, this is the plot of the instantaneous power. So same with the inductive load, inductive elements. Okay, so sometimes it will absorb and sometimes it will actually supply. Okay, positive, negative, and so on. Okay, so for the summary on the power calculation, so if your circuit contain only resistor, so your circuit will have active power, positive active power with zero reactive power. But if your circuit contain inductor, okay, the active power, which is P, is zero, but your reactive power Q, it will become positive Q. And for your, if the circuit is actually a capacitor, so same, the active power is also zero, but the Q is negative. Next, we go to the power calculations. So for example, here, so calculate the instantaneous power and average power absorbed by a passive linear network. If the VT is given 80 cos 10t plus 20, and the current is actually 15 sine 10t plus 60 degrees. Okay, so for this example, okay, I would like to show to use what I call the Microsoft whiteboard here. Okay, so I hope you see this board. So it's given that the VT is given as 80 cos omega t plus 20 degrees, and the both IT is given as 15 sine 10t, sorry, oh, this is 10, sorry, it's always okay, so this is 10t, so this is also 10t minus, sorry, plus 60 degrees. Okay, but always bear in mind that you cannot actually multiply directly, because P, we know that instantaneous power is just a multiplication of VT and IT, but you cannot directly multiply it because you have different function. This is cos and this is sine. So what you need to do is actually to actually transform this into a cos equivalent function. So the cos equivalent function can be write down as 5 cos 10t plus 60 minus 90 degrees. So which we can actually got 15 cos 10t minus 30 degrees. So so we can right now multiply this voltage and I, because right now the cos, the function is actually same. Okay, so based on that, we have our Vm is 80 volt, our Im is 15 ampere, our angle of the voltage is 20 positive, and our current is actually negative 30 degrees. Okay, and the function of the instantaneous power is VMIM, so 80 multiplied with 15 over 2 cos theta V minus theta I, so 20 minus negative 30 degrees. Okay, plus 80 multiplied with 15, so this one multiply over 2 cos 20 minus negative 30 degrees multiply with cos 2 10t. Okay, plus 80, 15. Sorry, this is not plus. This is actually a negative. The third term is actually a negative over 2 cos. It's not cos, it's actually a sine. Okay, sine 20 minus 30 degrees multiply with sine 210t. So by using calculator, so I can write down my instantaneous power. So this one will become, okay, so this one will become 385.7 plus 385.7 cos 20t minus